Trigonometry. The diagram shows a right-angled triangle. Work out the length of side Y. Give your answer correct to 1 decimal place. You can use trigonometry to find missing lengths in right-angled triangles. If you're answering a trigonometry question involving right-angled triangles, you could write SO, CA, TOA to help you remember the 3 trigonometric ratios. They are sine of x equals opposite over hypotenuse, cos of x equals adjacent over hypotenuse, and tan of x equals opposite over adjacent. Opposite, adjacent and hypotenuse are the sides of the triangle, and they're always labelled relative to the angle you're interested in. So this side is the adjacent, this side is the opposite, and the hypotenuse is always the longest side. That's the side opposite the right angle. In this calculation, you're interested in the opposite and the adjacent, not the hypotenuse. So choose the trigonometric ratio which doesn't involve the hypotenuse. It's tan of x equals opposite over adjacent. Substitute the values you know into tan of x equals opposite over adjacent. So tan of 53 degrees equals y over 4. This is an equation that you can solve to find y. To get y on its own, you have to multiply both sides of the equation by 4. So y equals 4 times tan of 53 degrees. You can work this out in one go using your calculator. Make sure that your calculator's in degrees mode. Look for this little D at the top of the screen. You can use the tan button to enter tan of 53 degrees. Write down at least 4 decimal places off of your calculator display before you round your answer. So y equals 5.3081 ... Finally, round your answer to 1 decimal place. It's 5.3 centimetres. Check that your answer makes sense. The diagram isn't accurate, so you can't measure, but 5.3 centimetres looks about right. You need to be careful when you're entering trigonometric ratios into your calculator. If you entered tan of 53 times 4 without putting another bracket in, you'd get the wrong answer. You can enter the calculation in this order, but you need to write a bracket at the end of the angle.